Today we're going to be talking about estimating quantities. Today I will demonstrate my mathematical ability to utilize my knowledge of ratios, fractions, and the laws of exponents to simplify exponents through class discussion. In 1723, the population of New York City was about 7,248. By 1870, almost 150 years later, the population had grown to 942,292. We want to determine approximately, or about, how many times greater the population was in 1870 compared to that of 1723. Well, if I look at these numbers, I'm essentially going to go 942,292. And essentially I'm dividing that by 7,248. Okay? Now I'm going to round these to the closest power of 10. Well, 942,000, okay, is close to 1 million. So I'm going to use 1 million here. Okay, and 7,248 is close to 10,000, so I'm going to use 10,000 here. Okay, so now I'm going to use my power of 10 because I want to know how many. So it would be 10 to the 6, that's a million, divided by 10 to the 4th. My laws of exponents says that when I'm dividing, I can of the same base, I can subtract the exponent. So 6 minus 4 is 2. So 10 to the 2nd. Okay? So, and 10 to the 2nd equals 100. So therefore, it's about 100 times more people in New York City in 1870 than there was in 1723. Okay? Once again, when I'm looking at trying to get an approximation, I'm going to round to the nearest power of 10. Okay? And then I'm going to write it as a power of 10. Use my law of exponents. That's how I got 10 to the 2nd, and that equals 100. Okay, let's look at something more local. I want to compare the population of Wichita to the population of Kansas. Specifically, let's find out how many times greater the population of Kansas is compared to that of Wichita. Okay, we're going to start out pretty much the same. So I'm going to put the population of Kansas right now is 2,894,000. Okay, the population of Wichita right now is 386,552. Okay, now I'm going to use my power of 10 here, and I'm going to look. I'm going to look right here. Okay, the 2. I'm going to start in my power or my 2 spot, which is in the millions. But I want to look. That 8 tells me I'm going to round this 2 up. So I'm going to round that 2 up to 3, because this is really close to 3 million. So that's really what I want to write over here. 3 times 10 to the 6, because remember 10 to the 6 is a million. I'm going to have 3 million. Okay? I'm going to divide that by, if I look here, I'm going to look at the 3, look at the number next to it, that's 8. It's larger than 5. I'm going to round it up. So I have 4 times 10 to the 5th. Okay, because we're looking at 100,000. Now, I've talked about this before. Separate this out right here. Okay. 3/4 is the same as the decimal 75/100. So I'm going to use a decimal here because I'm going to want one answer in the end. Times 10. Okay. 6 minus 5 is 1, so times 10 to the 1st. Okay, so which is just times 10. So when I take 75/100 times 10, I end up with 7.5. So what does that mean? That means that the population of Kansas is 7.5 times larger than the population of Wichita, when Wichita is our largest city. Okay, so in the end, when I'm looking at, the population of Kansas versus Wichita, it's 7.5 times larger than that of Wichita. Okay, it says the average American household spends $40,000 each year. If there are about 1 times 10 to the 8th households, what is the total amount of money spent each year by the American households in 1 year? Okay, well, so I have 40,000. Okay, if I want this written to a power of 10, it's going to be 4 times 10 to the 4th. Okay, now all I have to do is simply multiply this times 1 times 10 to the 8th. Okay, now I can use my, and really what this all boils down to, let's look again, I have 4 times 10 to the 4th times 1 times 10 to the 8th. Now, I can use my commutative property here and change the order, so I have 4 times 1 times 10 to the 4th times 10, times 10 to the 8th, right? Now, 4 times 1 is 4. 10 to the 4th times 10 to the 8th. Remember when I'm multiplying, I have the bases that are the same. I can add the exponents. I have 4 plus 8, which is 12. So 4 times 10 to the 12th. Okay? So therefore, the American household spent about 4 times 10 to the $12 each year altogether. And I could write this all the way out if I wanted to get the exact number. It's $4 trillion we spend each year. Okay? That's a lot of money. If we spend all that money, we can help get our... No, never mind. Alright, let's look at one last example. Okay, here it says the average person takes about 30,000 breaths per day. Alright, express this number as a single digit integer times a power of 10. Well, so I have 30,000. The 3 sits in the 10,000s place. So I'm going to have 3 times 10 to the 4th. Okay, I have a single integer, and it's written to the power of 10. Pretty simple, right? Let's look at the next one. It says that the average American lives about 80 years, or about 30,000 days. How many total breaths will a person take in their lifetime? Well, 30,000 days and 30,000 breaths are the same, so I'm going to use the same number. So I have 3 times 10 to the 4th times 3 times 10 to the 4th. Just like we did on the last one, I can use the commutative property. I'm going to change the order, so I have 3 times 3 times 10 to the 4th times 10 to the 4th. Okay, 3 times 3 is 9. 10 to the 4th times 10 to the 4th is 10 to the 8th. So the average American is going to take 9 times 10 to the 8th breaths per year. Or if I write this out in standard form, it's going to be 900 million breaths in a lifetime. That's a lot of breathing. Holy cow, we breathe a lot. All right? Now, make sure you fill out your WSQ and bring it to class.